Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at quadratic sequences. So specifically, we're going to look at coming up with the formula for a quadratic sequence. Now the formula, because it's a quadratic, will always be of this form. So remember, this means the value of term n, and it'll be an squared plus bn plus c. When I say we want a formula, we want to be able to substitute the value of n. We want to be able to insert into the formula which term it is, and then it calculates what the value of that term is. So how do you recognize a quadratic sequence? Well, let's look at this sequence here. Now, it's clearly not arithmetic. That's because we're not going up by the same amount each time. We added 2, we added 6, we added 10. It's also not geometric because we're not multiplying by the same amount each time. So the reason it wasn't arithmetic, as I said, we went up by 2, up by 6, and up by 10. So there isn't a common difference. We call this the first difference. So arithmetic sequences need to have a common first difference. But we'll see there is a common second difference. That's the difference between the differences. So the difference here between each of these first differences is 4. So the next term following this pattern, we'd go up by 14, and that would give us 35. The second difference is always common. The amount by which we are increasing each time is increasing by 4 each time. So this is called the second difference, and a sequence is quadratic. It'll have a formula of this form if the second difference is constant, as opposed to arithmetic, which means the first difference is constant. So I'll call this second difference k. Turns out that for any quadratic sequence, the value of a is always whatever k is, whatever the constant second difference is, divided by 2. So in this case, we had the second difference was 4, so a is equal to 4 over 2, which is equal to 2. We found a. So what we're going to do now is subtract this term here. So what we found so far, this will be Tn equals 2n squared. Now the rest of this, the bn plus c, this is linear. So what will happen is if we take each term and subtract this term 2n squared, we will end up with a linear sequence, which means it will be arithmetic. So what I'm going to do is set up a table. I have my n values, the number of the term, and tn values, the value of the term. I'm going to take my tn and subtract 2n squared. So 3 minus 2 times 1 squared just gives us 1. Here, 5 minus 2 times 2 squared is equal to negative 3. 11 minus 2 times 3 squared is equal to minus 7. 21 minus 2 by 4 squared, you can just use your calculator for all this, is minus 11, and so on. You can see here in red we have an arithmetic sequence. So what will this be? Well, that is Tn is equal to a, the first term, plus n minus 1d. So plus n minus 1 times d, which is negative 4. So what we do now is expand the brackets. So we get minus 4n plus 4. We get negative 4n plus 5. So all we do now is add that on to our 2n squared. The formula for this sequence, we found Tn was equal to 2n squared, and now we just add the minus 4n plus 5. This formula will give you the value of any term if you substitute into it the value of n. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.